Hello, Math 3 students. Mr. Eicher here, looking at a Chapter 9 and 15 review. This should be pretty fresh. It was just a week or two ago that we were talking about sequences and series and three-dimensional figures. So my plan in this first page, we'll look at some stuff that we'd like you to know about sequences and series. And then in the next video, we'll look at the next page, which is about three-dimensional figures. So we'd like you to be able to identify if a sequence is a geometric, arithmetic, or neither. So for instance, arithmetic sequence, say we start at 7, and then we have 10, 13, 16, etc. We should be able to fill in the blanks. That's arithmetic. We have a common difference. We're adding 3 each time. It's a positive 3 that we're adding each time. So the next number is 19, 22, 25, etc. That would be arithmetic. Example of a geometric sequence. Let's say we start at 3, and then we have 6. Now let's make it -6. And then we have 12, and then we have -24. See if I did those right. That would be an example of a geometric sequence. My R, my common ratio that I'm multiplying by, is -2. So each time multiplying by -2. And you should be able to find the next 3 terms in that sequence. An example of something that's neither, maybe this one. Now there is a pattern for this one, but you're not adding a common difference and you're not multiplying by a common ratio. So this is neither arithmetic sequence nor geometric sequence. This is a special sequence called the Fibonacci sequence, but it's not arithmetic and it's not geometric. It's kind of a recursive sequence. So we'd like you to know that information. We'd also like you to know how to find the sum of a geometric series. In your notes for the final exam, you would probably want to have this formula. Here's one of the formulas for a sum of n terms of a geometric series. You have your first term, a sub 1, minus your last term times your rate, all divided by 1 minus your rate. So in this example, it looks like it's multiplying by -2 each time. So R is -2. Your first term, a sub 1, is 1. And your last term, a sub n, is 4096. So to find the sum, if we were to add up all those terms, to find the sum, we'd have 1 minus 4096 times your rate, all over 1 minus your rate. So that looks like it would be 1 minus 4096 times -2. Our numerator we get should be 8193, and then divided by 3. So our sum is 2731. Now you might wonder, how can my sum be smaller than one of the terms in the sequence? That would be a good question to ask. Well, that's because some are positive and some are negative. So some of the negatives are pulling away from the sum. So we get an answer of 2731 for the sum of a geometric series using this formula. There is another formula for for geometric series that maybe we'll review later, but let's just move on. Number 3, we'd like you to know how to work with sigma notation and to find the sum of an arithmetic series. It's going to be arithmetic, so just wait and see. If you're not sure what type of series it is, then you can plug in, you can make a table basically. You have I, and then you have the, as we call it, Y. So if you plugged 5 in, 5's the bottom number, that's your first term, plugging in 5. So that would be 2 times 5 plus 1, so 11. If you plug 6 in, you get 2 times 6 plus 1, so that's 13. If you plug 7 in, you'd get 2 times 7 plus 1, that's 15. And then you keep going on and on until you plug in the last number, which is the 100. That would be 2 times 100 plus 1. That's 201. So can you tell, based on this pattern that we have, what type of series? Is it arithmetic or is it geometric? Well, it looks like each time you have a common difference of 2. So this would be an arithmetic series with a common difference of adding 2 each time. You can tell that from right here. There's that 2 that turns out to be increasing it by 1 each time. So to evaluate this sigma notation, we could use the formula for arithmetic series, and the formula would be the sum, capital S, of n terms of an arithmetic series is the number of terms divided by 2 times the first term plus the last term. We have the last term right here, that's a sub n is 201. And we have the first term, which is a sub 1, that's 11. And now we just need the number of terms. The number of terms is how many terms are there from 5 to 100? How many terms is that? Well, that's a lot to count on your fingers, but if you want 1 to 100, that's 100 terms. And this is just not including 1, 2, 3, and 4. So we would have 96 terms. So be really careful. Don't just do 100 minus 5. If you did that, that's not going to give you the right answer. That's 1 off. So really, if you're going to do that, you always have to add plus 1 to that to get 96 is your n. So using this formula, we'd have the sum of these 96 terms is 96 over 2. The first term is 11. The last term is 201. And that would give us 10,176. That's evaluating sigma notation. 2 other topics we'd like you to be able to do is finding certain terms in a sequence. So the first one is find the nth term in an arithmetic sequence, and the next one is find the nth term in a geometric sequence. So find a sub 30. So a sub 30 is what we're looking for. That also, though, tells us, really important to note, that tells you the number of terms is 30. If you want to know the 30th term, then there must be 30 terms. And then the first term in the sequence is negative 20. And then the common difference, since it's arithmetic, you're adding or subtracting something. It looks like you're adding 7 each time. So another formula that will be helpful for you on your final exam is the arithmetic sequence formula, which is a sub n equals the first term plus n minus 1 times the common difference. So you're looking for the 30th term. The first term is negative 20. N is 30. And the common difference is 7. So this would be negative 20 plus 29 times 7. So we get negative 20 plus 29 times 7, which is 183. 183. So this is the 30th term, is 183. You could always check your answer. You could plug in your calculator and start just adding 7 every time and see if you get to 183 eventually. And then the next question we have, we're looking for a sub 15. That's what we're looking for. Notice that 15 tells you your n. If you're looking for the 15th term, then that means you have 15 terms. N is 15. And then a sub 1 is a very nice 1. And since we're told this is geometric, we have to figure out what is the common rate that we're multiplying by. Well, you had 1, and you multiplied by r, and you got negative 1.5. Or you had negative 1.5, and you multiplied by r to get 2.25. So to figure r out, it looks like r would just be negative 1.5. That should be equivalent to 2.25, divide both sides by negative 1.5. That should give you negative 1.5 when you do that, and it does. So your r is negative 1.5. So r equals negative 1.5. The geometric sequence formula is a sub n equals a sub 1 times r raised to the n minus 1. So this formula is for arithmetic series. This formula is for geometric series. So plugging in the numbers, we want a sub 15. We want the 15th term. The first term is 1. The rate is negative 1.5. And n is 15 minus 1. So we would have basically negative 1.5. The 1 out in front isn't going to change anything. Negative 1.5 raised to the 14. Negative 1.5 raised to the 14. And we get negative 291, negative 291.9292603. 9292603. So that is our 15th term in this geometric sequence. Thus ends this video. Thanks for watching. Give me a thumbs up if you like the video. And I'll see you next time in the second part of this review.